This is the first of probably 2 or 3 videos that relate to the fire tests that pertain to approved document B. And the first one we're going to go through is the reaction to fire. Now, reaction to fire effectively has replaced the surface spreader flame that we have had for years that has been tested to BS 476 Part 7. Classes 1 to 4 and BS 476 Part 6, which is Class O. The photograph's got nothing to do with reaction to fire. That's a BS 8414 test for facades, for high-rise facades. And if you want to know what a 3 megawatt fire looks like, then that is a 3 megawatt fire. But that may be a subject for a future session. Anyway, there is a national class on the left-hand side, and there is the European reaction to fire test on the right-hand side, and that is their rough equivalents. The tests are insanely different, apart from that test there, the BS 476 Part 4 test. That's incredibly similar to each other. But having said that, the national class in the new approved document has gone. So we don't have to worry about it anymore. So that simplifies the situation. It's been a problem for 15 years having to marry these two up. But that is, well, it's according to the guidance that's behind us, but I'm sure there will be decisions to be made in the future in relation to products that haven't been tested to the European class. Anyway, what we have is 5 classifications and 4 tests. And when I say 5, the reason is we've only got 5 is because they are not mentioned in ADB, so we're not going to worry about them. What we, like I said, we've got 5 classes and we've got 4 tests. And there's an element of hierarchy. They are hierarchical, the tests, to a certain extent. And what we can do is kind of split them into 2 groups. We can split them into that group there. And we can split them in that. So we can split them A1, A2. And we can split them B, C and D. And effectively there's 2 tests for each one, with 1 test floating between the 2, which is the 13823 test, the single burn item test. We all know that A1 is non-combustible. Hopefully we know A2 is limited combustibility. B has got a minor contribution to a fire. A reduced contribution to the fire. C's got a minor contribution, and D has got a medium contribution. So that was possibly why E and F weren't allowed in, because the contribution to the fire would be excessive. Another interesting fact that came out of all of this is anything above Class B will not contribute to a compartment flashing over, i.e. the temperature rise won't, within the room, will have nothing to do with the linings. Well, it may have something to do with the linings, but it won't contribute to flashover. That's what they say. So what we're left with is this. There we go. We've got 2 tests for A1, we've got 3 tests for A2, and we've got 2 tests for B, C and D. Not going to go into them much at the moment because we're going to go into them in further down the line. But there's a few examples of the products. A1, non-combustible, concrete and steel. A2, limited combustible, mineral wool. Class B, plasterboard. Class C, nothing naturally kind of slips into that class. Lots of Class B products will be used in areas where Class C is required. And lots of materials can be upgraded rather to Class C, and timber is one of them. Timber's Class D, but is quite easily upgraded to Class C. And of course, B, C, and D are all combustible. This is what I was referring to in relation to being hierarchical. We'll do B, C, and D first, and the start point on B, C, and D is the small flame test, and that checks the ignitability of the product. And that's not a bad place to start. There is videos and training courses. It's where it's the ignitability of the product is what effectively starts the fire. So it's not a bad place to start. So it's an ignitability test, incredibly simple. We're going to go through it in a minute. But unless you pass that test, you can't go on to test the product in accordance with 13823, which is quite an involved test. Lots of criteria are tested, and lots of data comes out in relation to the total heat released from the product, the rate of heat release, the smoke release, the rate of smoke release, the lateral flame spread, and the droplets. So quite all the stuff that we're aware of, the B, S3, D2, it all comes effectively from that test. And those tests, and depend upon what the results of those tests will depend upon whether you get a B, C, or a D classification. Same thing tends to happen on Class A and A1 and A2. I'll start on A2 because A2's start point is the 13823 single burn item test, this one here. Unless it achieves a certain heat release and heat growth rate, it can't then progress to do the non-combustibility test and then do the calorific value test, which will then determine whether it has an A2 classification. So A2 kind of a similar kind of approach, and A2 in fire performance terms is very similar to Class B in relation to that test. Class B products aren't tested in accordance with the A1 and A2 products, so we don't know how it performs when the product is mashed up and put into a furnace. So we don't really know that. In relation to A1, the start point is generally the non-combustibility test. So the start point is here, and it'll be tested for those two tests, the 1182 and the 1716. And if it achieves certain values, it will have a classification of A1. So that's basically a kind of quick description of the hierarchy of the tests. And that more or less sums up what I've just said on the previous slide, really. B to D, the 1192 and the 13823, the small flame test and the single burn test determine B to D, and Class A1 and A2 is determined by the single burn test, the 750 oven test, and the calorific value test, which we will go through all of. So here is the small flame test to 11925. It doesn't come any smaller than this. The apparatus is a small Bunsen burner-like flame. It's only 40 watts, about 6 or 7 matches, and that is offered to the sample that's located in a steel test rig, so to speak. And there's 2 lines marked on the test test specimen, 150 millimeters apart. The flame is offered to the bottom line, and it is applied for 30 seconds, and then it's taken away. And within 30 seconds of that flame taken away, if the flame exceeds the second line, then the test is failed. It's an ignitability test. It's testing the ignitability of the product. There was a BS476 test that tested for ignitability, but it never actually found its way into the regulations. It just didn't, for whatever reason. So, like I said, it's a pass or fail test, and as you can see here for Class B, it's exposed. The flame's exposed for 30 seconds, and then the flame's taken away, and within 60 seconds of the test commencing, the flame can't spread past 150 millimeter line. Now, it also has facility to test the sample from the bottom and from the sides. If the bottom and the sides of the product are exposed as a result of the general use of the product, then the product must be tested on the edge as well. So that's quite important. Especially, it's important on composite panels where the core of the product is flammable. There is a test apparatus, and there is the burner, handheld device, just to give you a bit of an idea of scale. There is the apparatus in full flow, and on the left hand side there is you can see the 2 lines 150 millimeters apart. I assume that the 2 lines are 150 millimeters apart. There's 3 lines there just to confuse the issue, but the 150 is the only measurement that's relevant. And if the product ignites and the flame exceeds that 150 millimeters, it's a fail. The left hand side is an obvious pass, and the right hand side is a fail. So the left hand side could progress to be tested for either B, C, or D, and the right hand side would either achieve an E or an F, dependent upon how long it took that flame to get to that particular point. There is another test failure of the product, and here is a summary of the test. And as you can see, this test, the photograph of this test shows the product being tested on the edge, which is a good idea. But like I said, it is an ignitability test. So I think the purpose is, well, we don't want anything that's easily ignitable. So we'll give them, we can isolate the product, the building products that's very easily ignitable, and they're the products that's going to be E and F classifications, and they are not acceptable in approved document B or any of the supporting guidance. So what it says is the sample size is 250 by 90. It can change. There's a couple of variations on the test, but this is going to be good enough. 40 watt flame. The flaming droplets are observed on this test, but you can't fail this test as a result of failing droplets. Test lasts for 30 seconds. Well, the flame's there for 30 seconds, and then it's observed for another 30 seconds. So the whole test will last a minute. And we can now show you a quick speeded up version. Well, this is the small flame test. Goes into his cupboard, gets his sample, measures it out, cuts it, puts it into the steel rig. Steel rig's then placed into the apparatus. The flame's identified to the line. It's in there for 30 seconds. 30 seconds observation. Takes the sample out, measures it, and writes up his report. And that is more or less it. Okay, on to the single burn item test, the SBI test. I think this is the kingpin of the test system, of the test systems to 13501. It's a medium scale test, and the sizes of it's generally for panel products, and the sizes of the panel products are 1500 by 1000. That is this fella here. That's 1500 by 1000, and that fella there is 500. 1500 is 500 by 1500, so it's 1500 high, and that is a corner burner unit, and it's kicking out 30 kilowatts, and that's direct. The flame's directly impinging upon the panels, and that's basically the test. There is many criteria that's tested in this, that's monitored in this test, I should say, rather than tested in this test. That's monitored in this test, and the fire growth rate is one of them, and that's calculated in watts per second. And the total heat release in the first 10 minutes or 600 seconds, whatever you prefer, that's calculated in megajoules. The smoke growth rate is calculated, but strangely calculated. It's not. It's monitored, and the same thing goes for the total smoke production. It's done by it's calculated by optical detectors, and how much light is prevented from getting to the sensors. I was under the impression it actually calculated the smoke volume, but it doesn't. It's a little less technical than that. I'm sure it comes to the same results, but that's basically how it's done. It's done via how much light is prevented from getting to the emitter, and the only thing that can do that is the smoke particles, because that's the only foreign product that exists where the sensors are. There's another two manually observed tests there. The first one, the lateral flame spread, and that is to the edges of the board. So if either of the edges of the board, if the flame spreads to the edges of the board, it fails. It fails B and it fails C. So B and C, no edge flame spread, and D, it's not applicable. Don't worry. Well, it doesn't worry about D. The other aspect that's identified is flaming droplets. So the flaming droplets, if they occur for more than 10 seconds during the test or less than 10 seconds during the test, is the criteria there. Well, there's three criteria. If there's no flaming droplets, it's 0. If there's less than 10, it is 1, D1. And if it's more than 10, it's D2. So that's basically how that is ascertained. So basically, from the fire growth rate and the heat release, that determines B, C, and D, and the smoke is calculated for S1, 2, and 3, and lateral flame spread is identified by whether the flame reaches the edge. And what was the last one? The last one was droplets, and of course the 10-second rule, and that identifies that. There on the left hand side is the burner. Now that is simulating a waste paper basket fire in the corner of the room. That's basically the simulation for it, what the thinking is. On the right hand side, that shows the proportions, and like I said, it's a medium scale test. And here it is, a little bit more information. 30 kilowatt burner, what we've said, replicates a waste paper basket fire. The sample size is, like I said, 1500 times 1000, and 1500 times 500, so that should be 1500. Got that wrong. Value is measured, total heat release, FIGRA as they call it, fire growth rate, a bit close to Viagra, isn't it? That could be heat growth rate too. Total smoke production and smoke growth rate, those are both monitored. Flaming droplets are monitored, and lateral flame spread is monitored. The test lasts for 20 minutes, and the observation time is 5 minutes. So that when the fuel to the flame is taken away, left for 5 minutes before the full observations are taken. So here is a video of it happening. This is the SBI test. Panel products as specified size-wise. The 30 kilowatt burner goes into the corner. The total heat release will be measured. The heat release rate will be measured. Smoke production measured. Smoke rate production will be measured. Lateral flame spread and the droplets. And now he goes in and puts it out. So here is the criteria for the various different classifications. That's what this slide is attempting to achieve. So if we look on the left hand side, it's probably a little bit more important than the right hand side, and I'll tell you why it's more important than the right hand side. It's because we don't have any classification as far, although we mention S3s and D2s and things like that. We don't differentiate. So at no stage in the game does the smoke or the droplets define whether a particular product is acceptable or it isn't acceptable. The only thing that determines whether the product is acceptable or not is the A1, A2, B, and C, and D. So you might as well forget about them for be aware of them. But like I said, there is no requirement in UK guidance for them. So let's go to the important things. So the first criteria is fire growth rate, and rightly so. And A2 and B2, A2 and B2, A2 and B both have the same fire growth rates for passing, and that's less than 120 watts per second. So basically, if you're starting off at 30 kilowatts, then after 1 second it can't be 30,120 watts. Then after 2 seconds it can't be more than 30,240 watts. So it works a little bit like gravity, this watts per second business. It's purely an acceleration rate. Class C can't be any more than 250 watts per second growth rate, and D 750. For A2 again and B, the total heat release can't be more than, for the sample product sizes, can't be more than 7.5 megajoules. And C is 15, double that, and D is not applicable. It doesn't make no difference. And of course D for lateral flame spread doesn't make any difference. And the criteria for A2, B and C in relation to lateral flame spread is the edge of the panel product, where both panel products aren't the same size, so it's effectively 500 millimeters. I'll go through the smoke and the droplets, but like I said, it's not categorized anywhere. Every aspect of the classifications within approved document B will always have S3D2, which is the worst criteria. But the S1 is less than 50 cubic meters of smoke. S2 is 200, is less than 200, and S3 is more than 200. Smoke growth rate can't exceed 30 cubic meters a second, and can't exceed 180 for S2, and can't exceed and of course anything more than 184 S3. And the droplets, DO means none, D1 means less than 10 seconds, and D2 means more than 10 seconds. The next test is the non-combustibility test, and this is, like I said right at the beginning, it's an A1, A2 test. It's very similar to the old BS476 Part 4 test, so which makes me happy because I was a BS476 type of guy. Anyway, the sample of the product is prepared 45 millimeters in diameter, and it's 50 millimeters long. I was going to say furnace, and it's not. It's. Some people call it an oven. It's not an oven because there's no top on it, and the reason why there's no top on it is because you need to be able to observe the sample. But it's a furnace, and the 45 times 50 sample is lowered into this furnace. That's calibrated quite accurately to 750 degrees. Plus, there is some small tolerances, but for all intensive purposes, it's 750 degrees. And the reason there's no lid on it is because you need to be able to observe the flames, if there is any flames. Anything over 5 seconds must be recorded. Anything less than 5 seconds is not generally considered an issue. So it sits in there for anywhere between 60 minutes, or the equilibrium temperature between the furnace and the center of the product, and whichever is the longer. And then the product is taken out and it's weighed, and it's allowed to lose 50% of its mass. And generally, if it's this type of product that's going to be non-combustible, then the majority of that weight loss will be water at that particular temperature. So it's allowed to lose 50% of its mass, and at all stages the furnace temperature is monitored, and any temperature rise above that 750 degrees will be down to the contribution of the sample, and that is different for both products. So if you want A1, if you're looking for A1, then it can't lose more than 50% of its mass. We've already discussed that. It can't have any duration of flaming. although it will be allowed less than 5 seconds, because that's not considered as being significant. And the temperature rise of the furnace can't exceed 30 degrees. For A2, again, exactly the same, 50% mass loss is allowed. This time, the flaming durations can't exceed 20 seconds, and the temperature rise must not exceed 50 degrees. There is a short video coming up showing the test. Looks as if it's being carried out in somebody's front room, but there you go. This is the BS 1182 non-combustible test, and there is the furnace or oven, whatever you like to call it, but there is no lid on it, so you can observe the sample. The sample is 45 diameter, 50 long, located in the center of the furnace. And one of the criteria is flaming. If it's flames, then that's recorded. The other criteria is how much that sample raises the temperature of the furnace over and above 750 degrees. If it goes over 750 degrees, it must be as a result of the combustion that's being created by the sample. The sample's then taken out after an hour, or equilibrium has been achieved, and then it's weighed. And the product's allowed to lose 50% of its weight. And that's the test. And now on to the final test, which is a calorific test, calorific value test. This is a proper lab test rather than the other three tests are quite practical tests, but this one is pure theory. And well, not pure theory, but it's a very controlled laboratory test, as opposed to what we've seen up to now. So the first thing that happens is whatever the sample is. Now let's assume it's homogeneous. It's one product, a calcium silicate board, for argument's sake. Then you would mash the product up in a pestle and mortar and create a powder, and it would be tested. If the product is a sandwich board, for argument's sake, and say for argument's sake it's the outside is calcium silicate and something else is on the inside, some hydrocarbons on the inside, then both products would need to be tested separately, and then depending upon the volumes of the test, the calculations will be weighted to give a final value. So anywhere between 0.5 gram and 1 gram is mashed up in a pestle mortar to create a powder, and then it's mixed with benzoic acid, which I never expected to see this here. Benzoic acid is a natural product that's found in plants, but it must be very easy to calculate its calorific value, and it must be quite combustible, otherwise it wouldn't be used in the test. But the samples mix with benzoic acid and create a kind of tablet that's put into a crucible. And then the crucible, there's a firing mechanism attached to the sample, a firing wire, and that all sits within the apparatus that we see there. It all sits inside, because this is where it says it's a bomb. It is an actual bomb. It's an explosion that happens in there. Obviously, the vessel is stiff enough to take it. We're not going to have a situation where there's going to be shrapnel running around, flying around the laboratory. So it's a controlled explosion within a small vessel, and obviously that's going to create an explosion. The explosion will create heat, the heat, it will then transfer into a water jacket, and the rise in the temperature of the water jacket will determine the calorific value of the sample. And that's basically how it all goes down. And there are, below the description there are the various different values has got to be achieved for A1 and A2. Won't go into that because the numbers, to be fair, the numbers don't mean anything. And I've explained if the product is non-homogeneous, that the various values are tested separately. And we will now watch the video of that test being carried out. It was like a 40-minute video, and I've heavily edited it. Must have taken him 20 minutes just to measure out 1 gram of the sample. It was painful, but like I said, the wonders of science, and we can edit it right down. This is the gross calorific value test, where in this case 1 gram of the ground up sample had been measured and placed in a crucible. And within the crucible you will see a firing wire being applied. There it goes. And that's effectively it's the fuse line, so to speak. That's the flask which will effectively accept the explosion from the test. It's quite substantial. That's benzoic acid being applied inside the flask at the same weight as the product. So if it was a gram of product, then it would be a gram of benzoic acid. That is then all assembled within the flask, and you will see it's quite a substantial piece of kit, as you can see, and that's all assembled. The valve on the top is for pressurizing, and here it goes. It's going to be pressurized with oxygen to make sure that the combustion process is complete. So we've got the oxygen, we have the fuel in the benzoic acid, and we're going to have the ignition by the firing wire. And then once that's all being carried out, the whole assembly will go into the apparatus, the measuring apparatus, which is effectively a water jacket. So when that controlled explosion within the flask takes place, the heat that's produced will heat up the water, and that's accurately measured by the sensors within there. And that will be then fed back to the PC that's monitoring it all. Here it is, and I've speeded that up, but effectively it's the heat, the temperature's accelerated up to about 23.5 degrees, and it's more or less stayed there, and that will be the data that's relevant to the test. Right, and this table summarizes all of the tests to the best of my ability anyway. On the left hand side we have the classifications A1, A2, B, C and D. Then we have smoke. For class A1, the smoke must be S1 and the burning droplets must be DO. Now it's the only area where they are governed, those two aspects are actually governed. In every other respect, A2, B, C and D. As far as the guidance is concerned, you're allowed S3 and D2, which effectively means they're not controlled. So that's that particular aspect sorted. The calorific value, it's got to be less than 2 megajoules a kilo for A1 and less than 3 megajoules a kilo for A2. Non-combustibility tests, obviously we know about the 50% rule, the 50% mass reduction. It's not allowed to flame, and the temperature of the furnace can't rise above 30 degrees. If it's A2, the temperature of the furnace can't rise above 50 degrees, and it can't flame for more than 20 seconds. In relation to the single burn item test, 13823, the medium scale fire test, the waste paper basket fire test, you could call it. Don't test that for A1. For A2, yes, it is tested, and we're looking for a fire growth of less than 120 watts per second and a heat release rate of less than 7.5 megajoules for A2. Small flame test, again, no and no for A1 and A2, but it is tested for B, C and D, and like I said, it's a pass or fail test for the small flame test. Otherwise you can't progress onto the single burn item test, the SBI test. Fire growth rate for A1's got to be less than 20 watts per second. For A2 and B, it is less than 120 watts per second. If you notice, A2 and B, both the fire aspects, both the heat produced and the fire growth are identical. The only thing that sets those two apart is that the A2 must go and do the non-combustible and the calorific value test. But to get through the SBI test, they're looking at exactly the same values. Fire growth for C is 250, as we mentioned, 750 for D. Heat release rate less than 4 megajoules for A1, which is quite a lot considering the size of the sample. The size of the sample is relatively small. B and A2 and B is 7.5, like I said. C is 15 megajoules, and D, it doesn't matter. And that kind of sums up the fire test in relation to the kind of data that you're looking for to achieve the various classifications. Now, the reaction to fire tests find their way right throughout the guidance of ADB, and here's just a couple of 2 or 3 examples just that I've pulled out almost at random. So if the staircase, if it's a single staircase, if there's only one staircase and it's over 3 stories high, for argument's sake, it must the material of the staircase must be A2, S3, D2. Remember, the S3, D2 is not controlled. So because we have always have the worst classification quoted, and we go to the bottom of the page. The treads must not be less than class B, and again S3, D2, worst classification for smoke and droplets. So that's one example. The majority of the examples of reaction to fire is contained within B2, internal fire spread structures, where we will start at the bottom of the page on circulation spaces. Circulation spaces is class B. You might as well not even mention S3D2 because it doesn't make any difference anymore now. Circulation space is Class B, which was the old Class O, and other rooms, Class C, which used to be Class 1. And there is small exceptions that there's exceptions to the rule that you can have Class D. So that's the guidance in relation to B2. B4, as we are well aware, any building over 18 metres that's residential, the external wall and its components must all be A2. And like I said, it's the only time where it's the S and the D is controlled. But to get the product through an A2 test that actually produces smoke and droplets would be literally impossible. It would be just too difficult. Because if it produced droplets, it would melt. It would lose its mass. It wouldn't pass the non-combustibility test, etc. And if the building is any other building, and it's more than a metre away from the boundary, and it's more than 18 metres high, then it can be Class C. And if it's less than 18 metres high, then there's absolutely no provision. So there's a couple of examples of the rules in relation to B4. In relation to roof lights, they sometimes need to be tested from the underside, and we look in there for a Class D. I'm not going to mention S3D2 anymore because it's, like I said, hopefully I'm getting that point across. And if the roof light from the underside will achieve Class C, then it will automatically achieve a B roof T4 classification. And that is it. And that concludes the video in relation to reaction to fire. I hope you got something out of it. Thank you very much. All the best. Bye-bye now.